Perfect.
Great.
I'm good too.
Thank you. Okay. Is there anybody at the center at Fairfield that is new today?
No.
No, everybody's there.
No,
Randy, it's very small on my screen. Can you tell me who's there?
We have Kathy and Elaine and Dave Robinson and Kevin and Reg and me. We're quite small today.
Okay. All right. Well, I mean, you've got the important people.
Well, of course.
we got the coffee.
There you go.
Yeah.
And is there, I think I recognize everybody that's online here. Okay, this is great. I just want to kind of say thank you to everybody for joining in. This is the Astro Cafe for the 26th day of January 2026. And all I can say is that I'm very happy that I live here in Victoria and nowhere else in Canada today. After all of the snow, seeing all the snow across Canada and the cold temperatures. So I think we should be very happy. We've also had some really nice nights. How many people have been able to get out and at least look up in the last week or so? Everybody's
Yay.
had a little bit of a chance to do that. Yeah, it's been just absolutely lovely. And the moon it's just been so beautiful. I can't remember it, like it's just kind of almost new, to look at things now compared to what it was. So I have Jeff giving a presentation, Randy giving a presentation, Chris Gainor, you've got some updates and some work on Artemis, is that correct?
That's right.
Thank you. There's lots of announcements, and I think David is going to talk a little bit about
Lauri, Lauri, are you able to see me? I mean, hear me? I think
yeah.
I think my camera's wrecked, so
Oh, okay.
I think
no, we can
you
hear
won't see
you.
me tonight. You only hear me
We can hear
tonight.
you. Yeah, okay.
Yeah, okay.
So David's got a few. Natasha's has got an announcement. I've got a couple of things. Is there anybody else that would like to add anything in this evening? Well, that was a resounding no. So let's move on. Let's move on to that, and we can get started tonight. So I wanted just to let you know that I am sitting in my den, and surrounding me, almost on, like, I don't know, 270 degrees, are Sid's books. I have hundreds of Sid's books sitting in piles on the floor, sitting in front of me, from when they gave us his entire collection
Oh,
of books.
Lauri, you have to
Yes.
show the camera. We have to see.
Oh, oh dear. Okay. All right. How do I turn around on with a? Oh, I don't know. Do you know what? My laptop won't let me do that.
Okay, sorry.
No, sorry.
Is it possible that you could take some pictures and share them somehow,
Yes.
either on
Yeah.
email or tonight or somehow?
Yeah. Oh, I was just going to say, I mean, they range from things that are from the like from the early 1900s. He's got some quite historical things, to volumes of things that range back in the 1960s and 70s, right through to some fairly modern things. And so I'm going to be talking with Alex, because I think I will give Alex the number one time to come and have a little bit of a look at what I have, and if there's anything that is good for the library, then Alex, I will let you take that. And then I think I think some of these books are going to end up on the tables at Astro Cafe, and then people can kind of take, I think, some things that they would like to do. We've got a couple that we could use up at the center, but there's a lot of books, and I really do need to be able to find a spot to be able to move through my den in the next week or so before I can get anywhere.
What is this book thing of which you speak?
Well, we who was talking? I didn't know who it was.
It was Dave Payne. I'm just making a joke.
Oh, Dave. Okay. All right. Well, Dave, there's some stuff on
Is it like
astrophotography
YouTube?
here.
Is it like YouTube?
Kind of. But on paper.
But on
No,
paper,
actually,
yeah.
let me add some
I
comments.
apologize.
Let me
Yeah,
add
it's
some
okay.
comments onto Lauri's comments. I have seen the books or sort of perused some of them. There's some real classics there. I don't know if we're going to keep them for the observatories like the VCO or the ones up at the CU. But for instance, if anybody remembers this far back, in the 1980s, there was something called Sky Atlas 2000. And raise your hand if you remember that, eh? Anyways, Sid has a laminated set, so they're kind of nice to have. Oh, Peter says he recognizes it. So, anyways, virtually untouched. There's kind of a laminated set of Sky Atlas 2000 along with the companion volume that lists all the objects. In addition,
There,
if people
Brian's showing it. Yep.
Oh yeah,
Okay,
and
nice.
in addition, there's at least one set of volumes. There's three of them of Burnham,
Yeah.
the Burnham Handbook.
Yeah.
So it's a classic as well. Probably not read very much anymore because of software apps, but it's certainly a classic. And there's quite a number of atlases in the collection. There's even a Norton Star Atlas, if anybody remembers those. You have to go back to the 80s to remember that.
Yeah.
But yeah,
Oh, I've got so much here. It's just absolutely overwhelming. Anyway, okay. So we'll make sure that people get a chance to have a look through some of these and see what we can do. I mean, I'm suggesting that we have a little donation box that, if people would like something, they can throw a loonie or a toonie in when they take something, and we can
Or a 50.
have this. Sorry?
Or a $50 bill.
Or a $50
yeah.
bill.
Yeah.
That's right. Exactly.
Fundraising,
No
always
problem.
thinking
Yeah.
fundraising.
Okay.
So Lauri,
Yes.
when do you want me to come over then?
Oh, well, I'll make a date with you, Alex. Yeah.
Okay.
I'll make a date. And just as Peter Jedicke is here. Peter, I don't know whether or not our group knows too much about Mr. Tovey, but I was just wondering if you'd like to just give a very brief summary of your friend.
Well, thank you, Lauri. Yeah, I suspect, other than yourself, I can't think of anyone in Victoria Center who would have had the opportunity to meet Mark. Mark did a PhD in cognitive science at the University of Ottawa, and then he grew up in London. And then after he finished his PhD, he came back to London, and that's when I met him. That was around 2016 or so. And so I think he did participate in our General Assembly when we hosted in 2016. But the one thing, of course, that's perhaps most notable as astronomy contribution is his poetry book, which is this year. Is there too much glare, or can everyone sort of see the cover there?
Good.
Yeah, so that's quite a story. And I forget, Lauri, if you had invited Mark to come on and present that to Victoria Center.
I don't think he did. I don't think he came on at that time to do that. But maybe at another time, Peter, you could kind of tell that story.
Yes.
But Mark just fairly recently passed away in London, and was also the director of the observatory
Curator.
The curator in
the
at
curator
University of
of the
Western Ontario.
collections and the historical stuff. So when we did our club, our London Center centennial in 2022, there was a national presentation during the online General Assembly of the RASC, and we were live at Cronin,
Yeah.
and Mark and I sort of stepped everybody through the building and showed the historical collections and so on. And the sad part, I mean, the sadness is personal because Mark was a wonderful guy, and I really miss him. But from a practical point of view, the most important thing is there really is nobody to lead the collections at the Cronin Observatory here in London. And other than maintenance, keeping things clean and keeping things together, because we use them so much in open houses, there won't be any further development on that now. That's the saddest part.
Yeah. Well, it seems to be a growing concern about people leaving things for the rest of us to pick up.
Yeah,
everywhere. So
I don't know if you, not many of you folks from Victoria Centre, I imagine, would get a chance to visit the Society office in Toronto. So on a slightly related topic, our Society archivist, Randall Rosenfeld, who's another real sweet friend, he recently decided to up stakes and move to the East Coast. So he's on the opposite side of the country now. Can't go into the office daily and or weekly even, and at the Society office and do the work as archivist. So he stepped down as archivist, and we have a new archivist. And my wife Diane and we went to visit the Society office. So a week and a half, I guess 2 weeks ago today, it was Monday. And we met the new fellow who had volunteered to be the archivist. He's much younger. He isn't even 30 years old yet. So there were plenty of good humored jibes in both directions there, but he's really quite an amazing guy. And I would encourage you perhaps to invite him to maybe come on an Astro Cafe in the future and talk about the Society's archive. That might be good for a number of reasons. Anyway, like I say, we were excited to meet him. And Randall's not left this planet, but he has left Toronto, which for some folks might be about the same thing. But anyway, a nice replacement there. Thanks for offering me the chance to say this all, Lauri.
thanks, Peter. Thank you. All right, we're going to turn over to Jeff Pivnick. Jeff has got our first presentation tonight.
Okay, thank you, Lauri. I'm just going to do a screen share then. So this is about coordinated universal time, which is something we all deal with. I'm going to just rearrange the pictures here. Bear with me for a sec. There we go. So this is sort of a rabbit hole I went down starting in December. It started innocently enough. I went to visit my son in Calgary in early December. And as I do sometimes when I'm going away, I just flipped through Sky Safari to see what was likely to be in the sky if there were no clouds. And going through Sky Safari, I came across the UTC setting and realized that it was a niggling irritation that had been going on for a long period of time. UTC, you probably can't see it, but UTC is certainly a component part of stellarium. We all run across UTC with any alt-azimuth settings if we're trying to share the azimuth with anybody at a different time zone. We're also talking about the universal time, the UTC. The thing that had bugged me always about it is that UTC doesn't stand for Coordinated Universal Time. And I always wondered, how that acronym came about and, why UTC became used for something that obviously isn't the acronym for. And that's what started the rabbit hole. So to start with, the explanation is quite straightforward, but it leads to a whole bunch of other issues. So UTC is Coordinated Universal Time. which should be CUT, or in the French pronunciation should be TUC, Temps Universel Coordinate. It's neither of those things. And it appears that in 1972, when there was the introduction of UTC replacing Greenwich Mean Time, a couple of international bodies, International Telecommunication Union and International Astronomic Union, selected UTC as a universal neutral abbreviation that satisfied neither the French or the English proponents of their own acronyms, but worked to replace GMT. And then we come to, and it was consistent with the previous use of UT naught or UT0, UT1, and UT2. So questions arise. Why are we replacing Greenwich Mean Time? I mean, I started, in my early days using Greenwich Mean Time, as I'm sure most of you did. And what's going on with all those other references, UT naught, or UT0, UT1, and UT2? So that's what started the little trek, and I'll walk you through it. So it really starts back in Britain in the 18th century, Britain's sea power. And with the emergence of the nautical clock, which kept precise time, to calculate longitude, there had to be a standard. And the Royal Observatory is in Greenwich, England, which is just down the Thames from London. And that was chosen as the prime meridian for use of navigation. At that time, Greenwich Mean Time wasn't any kind of universal standard. It was just a local standard for navigation, basically calculating longitude with ocean travels. The real problem leading to Greenwich Mean Time started with train travel in England. And the problem that arose was that people would normally look up at the sky, and when the sun was dead overhead, that was noon. And that, even within a time zone, it varied slightly. With the speed of train travel and the need for people to get on trains at specific times, there had to be some kind of standard arrived at in terms of a time zone for England. So they introduced Greenwich Mean Time, which again hasn't become a universal time, just an England time, but at least it satisfied the issues with train travel there for a period of time. But it was also a problem that was arising in other places in the world. I think, as you'll see in a moment, many countries were struggling with the idea of needing to coordinate some kind of time zone. And it kind of came to a head in New England in 1853 when two trains collided with 14 deaths and 17 injuries because both conductors had the right time. They were just using different local times. So again, the need for a standard time. This culminated in 1884 when Chester Arthur, then the President of the United States, called a conference in Washington, D.C. It was the International Meridian Conference, where they were trying to arrive at some notion of developing a universal time, that is a time standard to use around the world to coordinate things like navigation, commerce, communication, as the need to arrive on time and to be ready on time became something that was internationally recognized. So they decided to use the standard 24 time zones, each represented by 15 degrees. And there was some initial disagreement. I think some of the countries held out for a different meridian. All countries originally with navigation used their own capital cities as their meridian for their transportation calculations. But it was an almost universal choice eventually for the prime meridian to be that of Greenwich, England. And really, Britain being the dominant naval power, most nautical charts really identified Greenwich as a prime meridian because they were printed in England. They were used for commerce and shipping around the world. The publishing of the 1767 Nautical Almanac, which became a standard for locating lines of longitude using sextants at sea, again identified Greenwich as the prime meridian. So it became a reasonably straightforward choice. So again, Greenwich Mean Time was calibrated to the mean solar time at the meridian that ran right through the Royal Observatory in Greenwich. Interesting, when it started, there were two Greenwich Mean Times. There was the Civil Universal Day and the Astronomic Universal Day. The Civil Universal Day started at midnight, as we're used to. The Astronomic Universal Day started at noon hour, and it was adopted so that astronomers could do all of their observations within what was considered a day. That, however, didn't last very long, and I think it led to a lot of confusion. In 1925, the Civil Universal Day was adopted, replacing the Astronomic Universal Day, so that the day started at midnight. But they then referred to that as the UT time to avoid confusing, whether you were using civil or astronomic universal time. And both of those, and universal time, became the standard for Greenwich Mean Time. At that point, the second was defined in terms of the rotation of the Earth as being 1/86,400th of a mean solar day. And that's an 86,400 is purely the multiplication of seconds, minutes, and hours. So 60 times 60 times 24 is 86,400. But the problem arose that actually wasn't precise enough. And as time went on, it wasn't precise. The solar day was a little bit slower. And this is just, I pulled this graph out, even though it represents time. Apologize for that. Even though it represents times between 1973 and 2015, when things were measured a little bit more accurately, just to illustrate the problem. The dates are along the x-axis, the times and the years, and the variance in milliseconds is in the y-axis. And you can see that there's a really consistent variation away from the perfect 86,400 seconds making up a day. And anything, so this arrow that I drew on the graph is the line at which it would correspond precisely. Anything over that is longer, so that the orbit of the Earth was a little bit longer than what they used as the definition of the universal day or the universal time. So that led to, as it became more and more important to calculate time accurately, that led to the International Time Bureau in 1955 introducing a correction to the solar universal time. And they figured the major effect on that was actually the effect of the tidal forces of the moon on the slight wobble of the Earth, which is called natition. It's about a 18.5-year cycle of slight but predictable wobble. So the corrected universal time became UT1, universal time 1. They also recognized another type of variation, which was really unpredictable, although they called it seasonal. They thought it had to do more with gravitational attraction of other planets, perhaps melting of the ice cap. And they very accurate, but they introduced again slight additions, and they called that UT2, or second universal time. I think that became complex enough that they kind of the general decision was to use just the correction to universal time as UT1 being good enough for most astronomic calculations. So it was really it was good enough at that time for most people. So UT1 became then what was Greenwich Mean Time. Things changed in 1956. That's when the atomic clock was introduced with a very accurate way to measure seconds, and they identified and used an accurate offset to UT1. So again, becomes a little bit more accurate. Time goes on, things need to be a little bit more accurate. The International Telecommunication Union at that point adopted the name Coordinated Universal Time, and as we saw, that was the decision UTC, adopted in 1967 and implemented as a worldwide standard in 1972. And it was really officially the cesium clock offset for UT1, the cesium clock being the standard atomic clock. And I'll get into that for a moment. So the UTC standard, Coordinated Universal Time, replaced Greenwich Mean Time at that point, primarily because the latter was no longer considered precise enough for modern scientific and technological needs. The picture on the left is the original cesium clock from 1956, and the middle picture is just putting that in perspective so you can see how large it is compared to a person. And the picture on the right is the current version of the cesium clock, or the atomic clock. So Coordinated Universal Time used a consistent second. Greenwich Mean Time was defined as a specific fraction of a day, defined by the Earth's rotation, but the the Coordinated Universal Time was identified by a specific measurable atomic frequency. In particular, because I know you're all dying to know, the radiation frequency of ultrasound producing the energy required for a quantum jump between two energy states of the cesium outer shell electron was what came to define precisely 1 second, and each of those component parts are measurable. The quantum jump is measurable, so you can identify exactly the ultrasound frequency. And then you can identify exactly the length or the time needed for that number of cycles of the ultrasound vibration. And just in case you're still curious, it's 9,192,631,770 cycles, which corresponds to the transition between those two states of the cesium electron. So Coordinated Universal Time gave some clarity. It's now based on the average of about 40 or about 400 worldwide atomic clocks, producing a very precise definition. And it's stable. Greenwich Mean Time is based on Earth's rotation, on solar time. The corrections to it, UT1 is based on rotation, but the Coordinated Universal Time is based on an atomic standard, which is replicable. But this graph demonstrates that even with that, the Earth's rotation varies in a slightly unpredictable way. So this is now Earth's rotation, the mean solar day between 1965 and 2020. Anything above the line is slower. Anything below the time is faster than the 86,460, I believe it was, seconds. So again, the Earth is still a little bit slower than that defined by the cesium clock. So to solve that, leap seconds were introduced. Leap seconds were introduced to keep Coordinated Universal Time in sync with the actual corrected solar time of the Earth, so that rotation continued to be consistent. So this still allowed for a time standard that was scientifically precise and useful for civil timekeeping. The universal time is adjusted by 1 second intervals to ensure that the difference between the universal time scale defined by the atomic clock didn't differ from the rotational time of the Earth by more than 0.9 seconds. So the current state of the coordinated universal time and leap seconds is that the International Earth Rotation and Reference System Service, which is based in Paris, monitors the Earth's rotation, announces the need for leap seconds to be added about 6 months in advance. Leap seconds are added irregularly and at unpredictable intervals to universal time to keep it aligned with the Earth's rotation. On average, leap seconds have been inserted about every 19 months. Leap seconds are typically added at midnight on June the 30th or December 31st, so 6 months apart. Since the system was introduced in 1972, we've added 27 leap seconds to coordinated universal time to allow the slowing of Earth's rotation to catch up with the precise atomic clocks. The last leap second that was added was December the 31st, 2016. But there's still a problem with that. This is a graph of the 27 leap seconds that have been added. And as you can see, many were added initially and fewer have been added. And that's because the Earth's rotation is slightly speeding up and starting to catch up with the cesium clock. There's been a couple of ideas, a couple of theories about why the Earth's rotation is now speeding up. I think the one that's predominant these days is that the rotation of the mantle is speeding because of the slowing of the rotation of the core. So to maintain the conservation of rotation, the mantle is speeding up, and this is measured in milliseconds. So leap seconds have always been, and they increasingly introduce complications every time they emerge, just with all of the computer systems in the world. There was an international resolution adopted in 2022 to abolish leap seconds by the year 2035, just because of the speeding of the Earth and the fact that it was coming closer and closer to the time kept by the atomic clocks. After 2035, UTC isn't going to be kept within the 0.9 second difference from UT1. Two timescales may slowly diverge, although with the fewer and fewer needed leap seconds, it may be a vanishing problem. But anyway, it will be still monitored, and it's anticipated that there may be a correction every few centuries. So just a couple of other little tidbits. Z in the NATO phonetic alphabet is Zulu. And so Zulu time is the military and aviation abbreviation for coordinated universal time. They're synonymous, but Zulu time is used. The other thing, probably closer to home, you probably know a radio announcement now from Ottawa. This is the National Research Council official time signal. The beginning of the long dash followed by 10 seconds of silence indicates exactly 10 o'clock Pacific Standard Time, and that's what you folks would have heard here in Victoria. That was broadcast at 1300 or 1 p.m. Eastern Time across the CBC radio network. It was adjusted for both Standard Time and Daylight Saving Time. The signal was kept consistent with the Coordinated Universal Time, but it was maintained by NRC in Canada, and that was known as UTC bracket NRC. NRC maintained it within 100 nanoseconds of the International Universal Coordinated Time, or Coordinated Universal Time. They stopped using it October the 9th, 2023. I certainly do remember it used, up until the very recent past. There were concerns that because of radio broadcast transmission time, it was actually leading to more inaccuracy. They were sometimes had delays of up to 300 milliseconds with the transmission. The only other thing about it is that CBC claims it to be the longest running program, running between 1939 and 2023. So I guess the other irony about coordinated universal time is that, of course, it has nothing to do with universal time. It has to do only with the world time. And there is increasingly a need to create another type of time standard for the moon. And Randy was going to talk about that.
Thank you, Jeff. Oh my gosh. I learned a whole bunch that I didn't know. Dave Payne, you have your hand up?
Good, thanks, Lauri. No one watches the CBC anymore, anyways. But anyways,
It's radio. Radio. The medium is the message.
anyways, I think this is a demonstration of that there's friction in space. There's gases in space, and planets moving through space create friction. And the Keplerian idealistic model doesn't actually, to infinite precision, take place. And there are frictional effects. There's the Earth is moving through a medium given off by the sun, and this medium has different angular momentum around the sun at different times. It's got different rates moving away from the sun at different times. And this causes this variation at the very fine scale of the speed at which the Earth moves around the sun.
But Dave, there's also the chaotic turbulent systems of the fluids that make up the Earth, the atmosphere, the mantle, and the core. And so because of that turbulence, it changes our angular momentum or angular moment, and that changes the speed of the Earth.
Absolutely. You're absolutely right. Absolutely right, Randy. It's a combination of all these things.
And more. Okay.
All right. Go ahead, Randy.
So I'm going to share. So, yeah, I got this. I love it when people ask for Astro Cafe talks. So I'm a real sucker. I will talk about almost anything I'm asked for. And in this case, it was it was Jeff's writing me saying that he's doing this talk on universal time, and he came across this article in astronomy.com. What time is it on the moon? So just to encourage other people to do this is the letter he wrote. Here's an interesting moon-related topic, which I ran across in 2024 Astronomy magazine. And I haven't heard anything about it since. It relates to the challenges and complications creating a needed coordinated lunar time with pending lunar exploration. And yeah, so this is the actual article, and totally a new topic to me. So thank you, Jeff. And so the first thing is, why do we even need a coordinated lunar time? We've done fine for all these millennia and millions and billions of years. What's changed? And one of the things is that there's a whole bunch of missions going to the moon, and you know, it's a bit like those trains that Jeff was talking about. If people use different times, then coordinating all of these different missions is going to be a problem. And yes, we do care about these very small time differences. And in particular, we care about a proposed satellite navigation system that they might put around the moon. And if they're going to do that, they're going to have to do it in the time system of the moon rather than the Earth. And why is that? It's because of Mr. Einstein and, first of all, special relativity and then general relativity. And I am not going to be able to go through relativity with everybody here, and not just because we don't have time, but because I really, really profoundly do not understand it. So I remember reading about this experiment done in 1971. They put atomic clocks on airplanes and flew them both ways around the Earth. And there was this, 300 and some nanoseconds difference.
That's huge.
It's actually huge. And the deal is that, like, we pretend because it works at a human time scale, we travel through space and time passes. We all kind of live as if there's a common time frame. And one of the things, and this actually predates Einstein, once they figured out that light travels at a finite speed and that information can't be transmitted faster than the speed of light, then there's this whole philosophical thing saying that if you can't know something, so, if Leslie over there says hi, I don't hear that until those sound waves come here. And if he waves, I don't see it until the light gets to me. And so there is no way that I can anticipate that Leslie has waved to me during those nanoseconds that it would take for the light to get to me. So it is not part of time. Okay, we actually have this spatial separation, and that makes a temporal separation in cause and effect. Okay, that's as far as I'm going to go in it, because it leads to all sorts of difficulties in our human time scale and what's happening out there in, first of all, what's happening at very small distances, so at the quantum scale, and what's happening at very large distances, astronomical scales, where there's all this time between things. That's okay. I'm going to stop there. But here's an interesting thing for people to know, is that in 1 nanosecond, 1 billionth of a second, light travels 1 foot, 30 centimeters. That's something really handy to know. A foot per nanosecond is the speed of light. Okay? And so when they set up this satellite navigation system, GPS, Global Positioning System, they actually have to run the clocks at a different speed because 2 things. One, the effect of the Earth's gravity actually makes the time run fast. And then because the satellites are moving, it makes it a bit slower. And so there's this correction that you have to do. And so, we're talking, something like 40 nanoseconds, I think it is, a day difference. And when you remember that a foot a nanosecond, or 300 meters in a microsecond, yeah, I think those units on those clocks are actually in microseconds. Anyway, it doesn't matter. If you did not run the clocks on these satellites that are in a different gravitational field and going at a different speed, then every day our GPS would become something like 10 meters less accurate. And since, we are expecting to know when to turn right when our mobile phone tells us to. If that gets many tens of meters out, there's going to be a problem. So fortunately, the clever people who set up the system do understand relativity, and they've made it so that it works. Quite awesome. Okay, so first of all, the European Space Agency said, oh boy, we better make a lunar coordinated lunar time. And then NASA, and in particular the National Institute of Standards and Technology in Boulder, Colorado, they set about working out what is the time frame on the moon, given its gravity. And so these two people wrote this paper, which is frankly terrifying. It is so complicated, I cannot understand it. And so I'm not going to show anything from the actual paper, but I do want to point out that a clock on the moon will take an extra 56 microseconds per day, and that's an Earth day. Okay, so on the moon, that many seconds, 26,000 or whatever seconds, Jeff can rhyme off the number, I bet, is going to be different by 56 microseconds. Okay, and a microsecond is, no, was it a millisecond is 300 meters? A microsecond is 300 meters of light travel. Okay, so that means that we're talking kilometers per day if they use an Earth clock in the lunar GPS. So then the clever people set up what would be the coordinated lunar time. Oh yeah, this is an example that somebody talked about. Let's say this is a very common COVID experience, that you want to watch a movie with somebody on television, but you can't do it in the same room because, you know, you're in two different places. So what you do is you say, we're going to start the movie 3, 2, 1 now. But what happens if the speed that your friend is watching the movie is different than the one that you're watching? Then, as you're saying, oh my God, there is a bomb, and the other person says, what? I haven't seen a bomb. You know, it gets out of coordination. And so that is what would happen if we used Earth time and just applied it to the moon. Okay, just an analogy.
But there's no person on the moon to watch the movies.
Well, they're saying there's going to be, or there's going to be robots and things. So we don't want any crashes. Yeah. So just you understand how GPS works. It's the same as how this would work on the moon. What those satellites, there's a constellation of, I don't know, is it 30 satellites that are beaming down to Earth the time. That's all that GPS is doing. They're also giving their orbits, but mostly what they're doing is they're beaming down time, and then in your mobile phone, it's seeing what time different satellites are beaming down, and they know where those satellites are, and then it can do the triangulation to figure out where you are. It's quite amazing. Anyway, it's the same thing that would be happening on the moon. Okay. So yeah, this is a 2024 position paper or something. And this is the one that made all the news that led to that article that Jeff pointed out, saying that, first of all, timing is mission critical for navigation. And you need coordinated lunar time, and they put the C at the end just like they do on Earth. And it's not that it's a time zone. It's actually the clocks run at a different speed. And while they could keep beaming between the Earth and the moon, this is a way to make it more autonomous around the moon. But if people going to the moon are going to age at a different speed, which is wild to me. This is a thing called the twin paradox about, there are two twins, one's a space traveler and goes to Proxima Centauri and comes back, and the twin comes back and sees their earthbound twin's grandson, who's the same age, because one aged much older, faster than the other. It's very hard to think of it in terms of people, but it really does happen. It's been confirmed over and over again in experiments, and it's established. Okay, so it's a time scale and it's going to diverge. And the other thing that this paper makes really important is that it's not just writing a paper that's going to make it happen. It is getting all the countries that are sending things up to the moon. So, for a long time, it was just Russia and the US, but now there's oodles of countries and companies that are planning on doing things on the moon, and there has to be buy-in. So it's a political as well as a scientific action to set up something like this. And I think that's where I'm stopping it. So thank you, Jeff. It really is a topic I had not considered, and I find it very uncomfortable, this idea that clocks go at different periods. And it's not that clocks go at different periods. Space-time is distinct depending on the gravity of masses close by and the speed that things go. It's a fundamental property of space-time. The speed of light is not just a speed, it is part of the very structure of space-time. Wild. Okay, and with that, I'm going to stop because I'm saying things I don't even understand.
Well, thank you, Randy.
Does anybody have any questions?
I do.
Thank you.
Go ahead, Reg.
Mars coordinated time, because on Mars the atmosphere condenses in the poles, and that changes the moment of inertia of the planet on a regular basis.
So it speeds up and slows down.
Yeah, so they've got that to worry about. So Elon better factor that in when he gets there. So
oh yeah, part of the thing is they think that they should actually land atomic clocks on different parts. You heard Jeff say that the definition of universal time is based on the average of 400 atomic clocks distributed around the Earth. They are thinking that they're going to have to do that on the moon too, and have them talk to each other. And then they'd have to do it on the moon, and yeah.
yeah, there you go.
Well, that should keep us busy.
It seems like a lot of money for a few microseconds. Okay.
Well, Susan, you have your hand up.
There are gravitational anomalies on the Earth even.
Yeah.
And so that's another factor that's throws into.
Well, that's right. There'd be a different speed at the pole than at the equator, which is, like people at the pole are going to age at a different speed than people on the equator. Not very much, but it's measurable apparently. Susan.
You're muted.
Where'd you go? Oh, there she is.
You're muted.
Still muted.
She may be frozen as well.
Sorry.
Oh, there we go.
So slightly tongue-in-cheek,
there she is.
slightly tongue-in-cheek question, try say that fast, is if you're halfway between the Earth and the Moon, at which point does the two different kinds of UTC change between the
Okay,
Earth
well,
one
it's not actually tongue-in-cheek. They talk about this in the paper. And in particular, the important point to work out is the Lagrange point between the Earth and the Moon. Why, Susan? I don't remember. But they do say that the important point is this place, which is, I don't know, a third of the way from the Moon to the Earth, something like that. And there it is 58 microseconds per day. And then on the surface of the Moon, it's only 56. But yeah, so I would say you would change over from one to the other at the Lagrange point. Without knowing what I'm talking about.
But if you're being that
but you have to have some agreement among everybody about where it changes, otherwise they're still going to run into each other.
You're right.
But the moon's orbit's not circular.
Oh, Lordy, so it's going to keep changing in
It's
time.
going to change as the moon goes around the Earth. With a ground.
I think we better stay on Earth, guys. It's dangerous out there. Okay.
Okay, thank
Although
you.
I can show my picture of the moon that I took just on the way in,
Oh,
if you
sure.
want to give me
Yeah.
the photo again.
Yeah.
So yeah, we don't see this all the time. How do I do this? I'm not sharing. Yeah, I have to share again. Share. And get out of this. Get out of this. And go to did I pull the picture in yet? Let's see. Nope. So we're going here we go. So that was just outside my house half an hour ago. And it is produced by hexagonal plates of ice in very high up cirrus clouds. Cirrus?
Serious?
Yes. And so it makes that particular 14-degree, I think, ring around the moon. And I always love it when you get to see it. And like Aurora, you see it better in the image with your cell phone than you do with your eye. But it was very clear there tonight.
Doesn't look like any hint of moon dogs at all.
Again, this is with me hand holding a mobile phone. I bet you could see it if you.
Randy,
We're-
are you saying that there's only ever one ring because it has to be in an exact place?
Well, there's one ring because of ice crystals forming as hexagons.
Yeah.
Okay.
And it's how the light enters the hexagon and then exits. It refracts at that particular angle. So you got a whole bunch of randomly oriented plates. And it's kind of the same as a rainbow, but a rainbow is spheres of water, and this is hexagonal plates of ice.
But they're not randomly oriented.
No?
No, they have a preferential orientation because they tend to be falling.
Oh, and that's where you get the dogs. It's the preferential.
Well, yes, partly, but yes. Anyway.
I did talk about this at Astronomy Cafe years ago, and I could probably find it again, but there we go.
So is it the same as the sun?
It's a similar
Like,
thing.
When
Yeah.
you get the sun, when you get the circles around the sun?
I think so. You
Yeah,
seem
it's
to
the
know.
same thing.
Elizabeth. Yeah.
In very solar weather, we get that around the sun.
Oh, they're halos, but yes.
Yeah, halos.
Yeah. Okay, yes, yeah,
Or sun dogs.
circles, halos.
Yeah,
Okay.
sometimes it's, yeah.
Okay, there's going to be a test at the end, everybody. So I hope you'll be listening. Okay. Thank you so much, Randy and Jeff. It's just fascinating to be able to listen to people that have a passion for digging through rabbit holes. I just think it's just wonderful. So there we go. Chris Gainor has got something about Artemis and possible heat shields and things like that, I think. Is that correct, Chris?
The National Research Council official time signal. The beginning of the long dash following 10 seconds of silence indicates exactly 12 noon Central Daylight Time for Saturday, June 17th, 1995.
There we go.
Wait a few seconds. A long 10 seconds.
Where's the beat?
I think it's a long tone, isn't it? Or something like that.
Good afternoon, I'm Geraldine DeBron.
Did we miss it? We're all holding our breath.
You didn't hear it?
No.
Oh, I heard it.
It was a bad frequency for us.
Yeah.
Yeah, not the ending. Not the important bit.
Okay. Well, I could try again if you wanted.
No, that's okay.
Okay, we're fine.
It's not accurate anymore.
We know that
That's right.
everyone that listens to CBC knows what it sounds like.
That's right. So we'll be talking about Artemis, mainly about the heat shield, but I want to talk about, just mention a couple of things. Just let me put on the share for a minute. Okay, do you see the Artemis 2 thing? Send your name around the moon.
Yeah.
So this is just a thing. If you sign up for this, send your name around the moon, you will get a boarding pass that you can download as a souvenir of Artemis 2. And then they're going to carry a little thing with the all these names. Right now they have 3.5 million boarding passes and names that they will carry around the moon with them. But there's just a couple more days for this. So this is why I'm bringing this up now, because it's coming to the end. So if you just Google Artemis boarding pass, it will take you to the NASA website, and you can do that. Yeah, fortunately, things at NASA are kind of returning to normal now after all the year last year and having to talk about politics and all this nonsense. So we can concentrate on things like Artemis. One little political development I will mention is that I got news today that Bill Nye, the science guy, is going to retire as the CEO of the Planetary Society, although he will still be around as their chief ambassador or something like that. So, anyway, let's get to some more Artemis, and I will just do another share thing here, and this, and share. And so we should be seeing the crew of Artemis 2 there. And just where we were at a couple of days ago, the crew of Artemis 2 went into quarantine, which they routinely do before launch these days, so that because in the past they've had astronauts go into space with colds, which isn't very pleasant, or there was the situation with Apollo 13 where they were afraid that one of the astronauts had come down with measles or something like that, and so they actually changed the crew of Apollo 13 at the last minute. So preparations are going on. You can see Artemis 2 is on the pad now. It's been there for 9 or 10 days. And preparations are moving along. So we have a number of days in which it can be launched, and you can see the days starting on February 6th. There's actually just about 5 days in February where it can launch. Usually in the it's a 2-hour launch window, usually starting early in the evening our time. And that's to get the part of it is to get the lighting they want on the moon. They're going to be looking mainly at the far side of the moon when they get around the moon, and so that's why they have these limited dates. And this is I knew this was going to be the case because it was a similar thing during Apollo. There was only a couple of days each month where they could get to a landing site. But even here, even though they're not landing, they want to there are specific times that they want to go. So the earliest is February 6th, and which I think is a Friday, if my memory serves me right. And we'll see how that goes. It could be that it's postponed into March or even April, but we'll just have to we'll have to see. What I hear from the Canadian Space Agency is that there's a big press on. They really are hoping that it goes in February because they've got a lot of shall we say marketing efforts going on. And let's see. This is just what the flight looks like. It's once they launch, if everything goes all right, they will go for about 10 days or so. On the first day, they will do a couple of relatively, or they'll do 2 orbits around the Earth. One is not that great. It'll only be a couple of hours, and then they will do a second orbit, which will take about 24 hours. It'll go much higher, and then on the second day, hopefully they will light up the engines for translunar ejection. It will go around the moon after about 4 days after that, and they will not come in as close to the moon as the Apollo astronauts did, even the ones who didn't land. They would usually come in to about 70 miles or so of the surface. Artemis 2 is going to be about 4,000 or 5,000 miles off the surface when it goes around the backside. And so this crew could be seeing parts of the moon that have not been seen directly by human eyes. We do have photographs of pretty well the whole moon, and then they will come back, and the various parts of the spacecraft will separate, and then they will re-enter. And Jeff asked me to talk about this last part because there is some controversy about this. Here's a nice artist conception of Artemis 2 going around the moon, and so it's the heat shield. So I'm going to talk a little bit about the heat shield for these spacecraft. Now, we are used to heat shields on spacecraft. The shuttle had kind of a different system. It had tiles. But prior to the shuttle, and now now that we're going back to capsules like with Dragon and things like this, we have a heat shield. But when you're coming back at the higher speeds from the moon, you need a fair bit more protection than you do when you're coming back from Earth orbit. Now, Earth orbit, you're generally traveling at about 17,000 and some miles an hour. And usually when you're coming back from the moon, you're doing about 25,000 miles an hour. But it's not, that is not the relationship between the amount of heating you get when you come back. It's actually much higher when you're coming back at lunar speed. So I know when we had Apollo 8, which was the first spacecraft coming back with humans at lunar speeds, there was a lot of nervousness about that. And there is about this one, and I'm going to talk about it a little bit. Now, what you're looking at is on the right is the heat shield from Apollo 11. This is what it looked like when it came back from the moon. And then you see on the left a honeycomb thing. And this is actually a rare artifact of the Apollo program that I obtained about 30 years ago. And I have not actually shown it to anybody until now. And I have it right here in my hot little hands. This one of the people I spoke to when I was researching Canada's role in Apollo was actually lived out here out in Colwood, and for a time he worked for this outfit called Avco, which makes the heat shields, and he had that honeycomb, which was used for while they were figuring out how to make the Apollo heat shield, and he just gave it to me, so I have this little souvenir. I'm not sure if you can really see it in the photo of Columbia from Apollo 11, but you can see that there is a honeycomb structure in that, and what they did was inject sort of a substance that would harden and would form the heat shield. When it came back, it would take the brunt of the temperatures, which I think are generally in the neighborhood of maybe even 5,000 degrees. And that heat shield worked quite well for Apollo. Now we're going back to those speeds again after 50 years, and so they developed a similar heat shield for Artemis, and you can see it at the bottom, the bottom right, the heat shield as it looks when it's manufactured, and it's a little different from the Apollo one. Instead of having these little honeycombs like I have here, they've have those sort of larger structures. You can see the segments in all these heat shields, and so when NASA flew Artemis 1 in 2022, I believe it was, and Artemis 1 had a similar trajectory to Artemis 2. It went around the moon and then came back and re-entered, and had a successful splashdown when it came back, there was no suggestion, at least at the beginning, that there was a problem. But there was a problem, as it turned out, and you can see in these pictures at the lower left that there are little gouges coming out of the heat shield. NASA has spent a lot of time looking at this problem and deciding what to do about it. Now, the first thing that has to be said is that if there had been astronauts on Artemis 1, they would have emerged unscathed from the reentry. But NASA likes to be more careful of this, at least when they are aware of a problem like this. And so they spent a lot of time working on this issue. Probably, if they didn't have this concern, we would have been talking about this flight about a year ago, that it was scheduled for an earlier time, and they actually put it back until this year while they studied this problem. And one issue was that taking off the heat shield and putting on a new one was not really an option in their view, that they couldn't really do that. They'd have to build a new spacecraft to do that. And so what they decided to do is that they decided that they could live with this current heat shield, but they're going to change the reentry trajectory slightly, so it's a bit more gentle, and that there's the amount of heat on the back of the spacecraft as it reenters will not spike to the same degree that it would have, say, it was on the same trajectory as Artemis 1. And they've decided that this measure is enough. They feel confident that there will not be a problem when they re-enter. Now, of course, there's always people who disagree with that, and there's an article actually on the CNN website which Reg drew to my attention, which covers this pretty well and their concerns. But this situation has been fairly well studied. I'm sure the four people most concerned have signed off on it, and so that's kind of the situation. But of course, this week is an interesting week to be discussing this, because it's sort of at the end of January that NASA's worst accidents have happened. I think, what is it? It's the 26th today, and tomorrow is the anniversary of the Apollo fire, which took place in 1967, killed the 3 astronauts. And the following day is the 40th anniversary of Challenger. And a few of us will remember that. And they basically let that problem with the O-rings and in the solid rocket boosters just drift along, and then it finally bit them. And then February 1st, we have the anniversary of the loss of Columbia in 2003, but which is kind of a similar situation. But this one is a little different because it has been raised publicly. It's been discussed a lot publicly. it's been studied a lot, and they feel that they can live with this. But I presume future flights of this Orion spacecraft that they will be perhaps paying a bit more attention when they are building the heat shield. So that's basically the situation as I see it. So if anybody has any questions.
Reg, can you explain, so the trajectory, if they take a different trajectory, which I suppose would be less steep, more shallow, they'll be exposed for longer, but generate less friction, less heat? Is that the concept? Because
That's right. It won't be quite as steep, so there'll be less of a spike. But yeah, it might be for a little longer period, and I think they've probably one of the questions I can see the question is, oh, if it goes for a longer time, is that going to be a problem?
Yeah.
And I imagine that's a question that they have asked and studied too, and they reached the conclusion that they did.
Okay. Well, thank you.
Chris, has this become a bit of a political football with people that don't want NASA to succeed?
I don't think so. I think it's just an honest difference. After those mishaps that they that I mentioned at the end there, there's going to be some people who want to be more careful with things. So I guess if something does happen, there will be
questions.
Yes, there will be a
Yes.
lot of discussion afterwards, because this, I think there's going to be a lot of interest in this flight, and so if something happens at this stage, a lot of people are going to be seeing it live.
Reg here. What I read was when they're coming in for landing or into the atmosphere, they're going to try and skip it off the upper atmosphere once or twice.
Yes, yeah. That's kind of how they do it. When they and they've actually done that many times before. In fact, I think they did that with Apollo 11, because where they wanted to land Apollo or splash Apollo 11 down, there was some bad weather there, so they actually skipped it off to so that it would land a couple of 100 miles downrange from that. So this is not a new thing.
So Artemis has been dwelling in my brain rent-free for a while now. I was quite concerned about it, and there's only one that's taken off, so this is the second one. And I got great comfort when I learned that there's 4 engines on the main rocket, and they're the same engines that they used on the space shuttle, are a very, very close cousin to it. So they've been really well tested. So it's not as wild and crazy as I thought.
Yeah, well, actually, the booster rocket, it uses shuttle engines that have flown before. Although this will be the last flight for those engines, because it's an expendable rocket. And if Artemis continues using that SLS rocket, they're actually making new engines now, which are more efficient than the ones that this one has. But this uh, that's a reassuring thing. But I mean, this is a really dangerous mission, you know, and yeah, you know, we've been mentioning this a couple of times, but you know, a couple of weeks ago on the National, Jeremy Hansen was interviewed on TV, and you know, he didn't try and cover that over. You know, he said that it's dangerous. He may not come back in one piece, and he's talked about it with his family. You know, the launch is still very dangerous. You have those. It's kind of a larger version. You know, the shuttle had 3 of those engines on the bottom of it. This has 4, but it also has those 2 solid rocket motors that cause so much concern in the shuttle program. And these ones are actually bigger than what they had on the shuttle. So I mean, they've been tested in flight, and also they had ground tests. But I know there'll be a few people who will heave a little sigh of relief, you know, when they get, what is it, 2 or 3 minutes into the flight and those solids drop away. And then, of course, they're going great distances away from the Earth. So if there was some sort of medical emergency or something like that, you know, they aren't going to come back right away like they could if they were on the space station.
Does anyone else have any questions? Any other questions for Chris? Okay, well, the next time
No, Peter.
I think Peter does.
Sorry, Peter, go ahead. Sorry.
I was reaching for the little icon there. Chris, do you know, I've always wondered, how concerned are they about the phase of the moon? I mean, they're going around the far side. When they look back, don't they want the sun shining on the back side of the moon so they can actually see stuff?
That's right. Yeah. Well, that's you know, that's the plan basically. That's why there's, you know, there's only like 5 days in February, and then you have to wait till March, because that's
Chris,
kind of the plan. Go ahead.
I just checked, and that week spans the 3rd quarter. So it's only going to be half the backside that's illuminated.
Yeah. But
it's not like we're seeing it. It's not a new moon, which is going to be fully illuminated in the back. It's going to be half illuminated in the back, half in the front.
That's right. And I think I could be wrong, but I suspect that it's the part of the backside that'll be illuminated, it was one that was not usually illuminated when they went there during Apollo. Just because, you know, when they landed on the moon, they always wanted the LEM to touch down just at sunrise on that particular site, and so you know, like when Apollo 11 landed in the Sea of Tranquility, it was like you know, a crescent, you know, heading towards I guess the first quarter. I know there's zillions of movies where they always show a full moon, but it was actually you know, just not even the first quarter yet. And I thought I had heard some chatter that they wanted to get a really good look at Mare Orientale, which has not really been that well seen. There's a really famous picture that, and it might have actually been a mosaic that one of the lunar orbiters did of that. But we actually don't have very many pictures of that part of the moon, because we can see a little bit of it, you know, with a little help from libration. But you have to be in a certain place to get a really good look at it.
Yeah, and when they sent like the lunar orbiters that were mapping missions, they were always closer to the surface, weren't they? I mean, or have there been uncrewed spacecraft that took photographs from a vantage point far enough away that they would see the entire disk of the moon in the frame of the camera?
Yeah, I'm just trying to think of how they got that particular image, because they had 5 lunar orbiters that they launched, and then um, and they all worked contrary to expectations. So towards the end, uh, they sort of said, well, we've got what we need for the landing sites, um, and um, and so they were the last couple were a bit more dedicated to scientific things and might have been in a different orbit. I can't remember if that's what they did. And then there were some shots like that from Apollo, like when they would come out from behind the moon and then head on out, and they would get some nice views. But it was generally the other side of the backside, like around Tsiolkovsky and all that. I remember there was a lot of pictures like that. And uh, and they used to televise that. That was really neat. Even though those pictures are really crummy, actually, by our standards, but just really hauling the mail away from the moon, and it was kind of a view you didn't usually get. And then when they got back, they'd taken pictures with their film. But anyway, there should be some interesting views of the moon. They were cautioning a little bit that they wouldn't necessarily be always broadcasting in high def, and so that we might have to wait until they got back for some of the images and video that we'd like to see. But I'm sure it'll be a lot better than what we generally had from Apollo, even when it was live.
So on another issue, has anybody figured out or contemplated, will the sun reflecting off the spacecraft make it bright enough to pick up in our telescopes as it moves between the Earth and the Moon?
Well, actually, I was looking at some press releases when I was getting ready for this, and the NASA has actually asked some observatories, but also individuals, to look for that. And apparently they put in for this, I guess. They said, we're interested in getting offers from people, and they got a few, and they announced them. And of course, we have much better equipment in a lot of ways than they did back in 1970. So there's an interesting little site that has some pictures that people took during Apollo. Generally amateurs, and who is the guy? We have a member here, Chris. I've just suddenly forgotten his last name, but he's still around, although he doesn't come to meetings anymore. But he was involved, and they were taking some pictures while they were site testing for Mount Kobo in 1970, and got a couple of pictures of the cloud that was created when Apollo 13 had its accident. And so there's a little bit of that. So I expect there will be some more of that, and we should maybe keep an eye out. Somebody maybe saying, "Here's the coordinates to look for it." But
Chris, I believe the Education and Public Outreach Committee, through Kareem Jeffer, is asked to have something to do with that. So
right.
there could be something that the RASC is actually doing. So,
But yeah, I don't expect it'll be easy. But
no,
the the solar panels on Artemis might be a bit more reflective than Apollo was, because it didn't have these big solar panels. So, but we will find out. That's I don't recall pictures like that coming out during Artemis 1, but there'll be more interest this time. So
so Chris, the pictures of Apollo 13, it was Ernie Schmidt and Frank Younger who took the photos, and they used the Bowler and Shiven 16-inch telescope that was just had a new lease on life due to the hard work of
that's right. That's who took those pictures. That's right. Yeah. So I have very fond memories as an astronomer of Apollo 13, because the night that the Apollo 13 explosion happened, April 13th, 1970, I went to an Edmonton Center meeting that night. And I came home from the meeting and my parents said, they've had an accident at Apollo 13. So, of course, I went and switched on the TV and sat there until they gave up coverage about 2 or 3 in the morning. And I went outside. We had clear skies in Edmonton that night. And I saw my first comet, which was Comet Bennett. And actually, at least until they were wound up being occupied by other things, the crew of Apollo 13 was also looking at Comet Bennett. So so that was a kind of an unforgettable night for me.
thank you very much, Chris. I think unless there's any other questions, I think we've got a few other announcements and things to make before we end the night. But I think Natasha, can I just drop over to you to give us what you were going to talk about?
Sure. So, following on to the Artemis theme, this came out last year, but perhaps you've already seen it. This is Jeremy Hansen's mission patch. Does it look familiar to anyone? I hadn't seen it before, and it was really interesting because apparently he has a long-standing connection with indigenous cultures. And so he consulted one of his friends in that community to design the patch. And so it's a heptagon, and the various animals represent different aspects of the 7 sacred laws. So there's the buffalo representing respect, the eagle, love, the bear, courage, Bigfoot, honesty, the beaver, wisdom, wolf, humility, and turtle, truth. And as well, we've got the RCAF astronaut wings here, the North Star, and Grandmother Moon. So he's going to be wearing that and taking it up pretty soon. Hopefully all things go well. And so there's quite a bit of information background about how he worked with the artist Henry Guimont of the Skakeend First Nation in Manitoba. And it's kind of interesting. I know we're running out of time, so I'm not going to share everything. But yeah, I don't know if anyone has seen this patch before, but if not, I think it's kind of fun. I'm pretty sure you can probably acquire it through the space agency. Chris, do you know if the patch is available? Usually they are.
Yes, I have the patch in a cloth in a sticker form, and I think they might have some up at the CU, but I don't.
Never seen them.
They're limited supply, and I also have it on a T-shirt.
Oh, cool. Okay,
So,
well,
so yes, and this is Canadian astronauts always have an individual patch when they go up, and this isn't the First Nations one. I know my friend Bob Thirsk, when he went up to the when he made his he's been up a couple of times, and I know at least one of his patches was First Nations, and I think it was from the out here in the West Coast somewhere, one of the First Nations out here.
right. Yeah. Well, it's
Oh
definitely
yeah,
beautiful.
you can get them. So
Okay.
when I'm up at the CU, I think Lauri will probably mention that I'm going to be up there with some other people, and I'll have my T-shirt on.
Excellent. Okay. That's it.
Thank you. Thank you very much. Okay. David Lee.
Yes, and I'm back in visual form as well. Yeah, so there's a couple of things I'm going to show you. Last week at the end of Cafe, we were asked to go out and look for Aurora. I did go out and didn't really see much, but then there's a little story that goes with that. So let me just share. So what happened was I went outside and I didn't really see anything, and I think I asked around. I think I asked Lauri whether she's.
Oh, we've lost David again, I think.
Frozen.
I think, David, you are frozen.
At least it's a nice picture.
Yeah, David asked me to go out, and I went out about midnight or about 11:30, 11 or so, and I didn't see any, and I couldn't see
Yeah,
anything.
it was earlier than that. It was when Cafe ended, and I just had a quick look, and it was pretty cold out, and went back inside and fell asleep. But as I say, I did get up, and because I had this thing on my little checklist to do, I was going to look for Comet Schaumasse. So let me just start with this. So what I did was I pointed. You can actually tell. Schaumasse was actually near Arcturus, and that's actually Arcturus right there. And I just started photographing into the area, like I didn't really see too much. And by then, the sky was looking a little bit filmy, and I didn't know what was going on, but I just kept on taking pictures because you never know. And often, comets, if you're not looking for extreme detail and you just want to detect the head, you can just take a whole bunch of exposures. So I thought I would have to stack it because I think the comet was like Mag 97 or something like that. It wasn't super bright. So I found the best spot in the cul-de-sac for me to shoot. It was down a little ways from my driveway. I had to get out from under the overhead lights, and I started shooting. And the couple of things that did happen in the process of doing this, I heard birds, which was really kind of weird. Like I don't normally hear birds at that time of morning. I don't remember them. I always think of birds as being closer to dawn, right? But it wasn't really close to dawn. So I don't know. I heard some birds, and in the process of shooting these sequences, I thought, well, this is kind of odd. I started looking at some of the frames, and I started starting seeing a mist, and I heard the birds again. And then I looked up and I could see that there were some beams right above me, like very sharp beams. And then I examined some of the frames and I saw this. So I did see some aurora. Now I didn't want to disturb my sequence, so I kept on shooting. Needless to say, that was a really bad strategy because comet heads tend to be a little bit on the greenish side. So really, I'm kind of looking in green haze for a green comet head. So it wasn't very smart. But anyways, when I finally did get around to shooting into the more northerly direction, I saw this. So yeah, I saw lots of curtains. Now I think Joe, did you pop something into the collection of something from Peacock Hill or that had more of a purple cast to it? Joe, are you there?
Yeah, I did. It was definitely a violet or purple, brilliant
Yeah,
purple color. Yeah. It
yeah,
was
I didn't see
right near
much.
the
I didn't.
horizon. But that was a
No,
lot
do you
earlier.
remember?
That was 10:30.
Okay, so that's when I saw nothing from my neighborhood,
Yeah.
right? And then all of a sudden, it didn't last for very long, but there were these very long beams and then the curtains. And these are my great niece and I have this joke about orbs because she was photographing for Orion magazine, and they have these algae which have this kind of orb shape. And I don't know if anybody's familiar with people that take pictures of kind of like ghost kind of pictures. They often use a flash at night, and you get these kind of little orbs. Well, typically these things are like dust that are lit up by the flash, and but they're out of focus, right? Because they're really close to the lens. So that's what these things are. Uh, I was very close to a light standard, and I didn't shield the lens properly. So you see these out of focus things from basically dust, right? So anyways, that was my shot. I don't know anybody else who saw Aurora, except for maybe Joe, but I haven't heard of
I
any.
did.
Oh, did you? Did you have any
I
pictures?
Yeah, in fact, I posted them.
Okay.
I
Well,
could.
why don't we
Yeah, I I I went out about a half hour after cafe ended last week, and I actually
okay.
didn't see anything, but I thought, well, what the hell? I'll take some pictures,
Okay.
and I got some. So I've posted one on Facebook, and I've posted a couple in my Zenfolio gallery.
Okay. Well, I'm going to be really quick. Let me do my last thing, and maybe we can look at some of the other Aurora shots. So
We've
the
only
other one
got
of the
about 6 or 7 minutes, everybody. So
oh, okay, I'll be
yeah,
really quick.
yeah.
So VCO, very successful session. We saw Saturn with a couple of moons. We saw Jupiter at opposition with a couple of moons, and saw an amazing view of the trapezium. Wouldn't you say, Reg?
It was beautiful.
Yeah, it was really beautiful. But
People went.
Not quite
yeah,
yet.
I don't know if it was that extreme, Reg, but um, so but the one last thing I wanted to talk about was we did look at the moon at the very beginning of the session, and I apologize to Sandy and Wyman because I told them there were another set of craters because I only glanced at the atlas and didn't realize that these are not Ptolemaeus and Alfonso and the Erratum. I don't know what the other one, but these are indeed Theophilus, Cyrillus, and Katharina. And what I found really interesting, I did some reading about these craters. These are impact craters, but they kind of show the aging process. The top one, which is Theophilus, is you can see the peak in it. But then the one next to it, which is Cyrillus, it had a peak as well, but it's a lot more subdued. And when you get down to Katharina, uh, it probably had some sort of peak, but it was more flattened. So it kind of shows kind of the aging process of some of the craters. Anyways, I'm gonna let this go now. Reg, did you have anything that
Yeah,
you
if
wanted to
I
show?
can briefly share, is that okay?
Yep, yep. I'm just gonna release. Let's see. Oh, wrong place. There you go.
Okay. Here. In the slideshow. Okay, so this was on Friday night, and it was a beautiful evening. And I just wanted to talk. This is an aggressive marketing session for the BCO. And if people haven't been there, it's this little shed here at the top. And if you're an MIC and are frightened about the complexity of going up there, the members in charge, there's a cheat sheet and you just have to follow the directions and you can easily operate the scope. And the first thing is that what's up there? There's a 12.5 inch Ritchie-Crenshaw scope on the left here, and then a 5-inch Takahashi refractor. And this is the first light with the Takahashi. I've got a camera on it and it shows up there and it actually worked. So you could easily switch from visual to optical, and it takes about a minute. And last night we had on Friday night, we had great fun looking through these various things at various powers, and it was a communal experience. Everybody oohed and awed, and I really enjoyed the views. And after it got a bit chilly, I slapped a digital single lens reflex camera, Canon T3i, basically Canon Rebel. And I'm sure a lot of people probably have got them lingering in their closet somewhere because they're always using phones now. And this is a great way to repurpose your old scope because we have the hardware to click this onto the back of your camera, and away you go. It only takes a few pieces here, and it's really easy to do. And so I took some pictures here, and this was of the Orion Nebula with the T3i. We're having a bit of a problem with the Ritchie-Crenshaw scope, but this is the first time I've taken a photo of Orion, and it's like photographing a light bulb. This thing here is such that I took 10-second exposures, 41 10-second exposures to get that because it was so bright. So you could probably take those pictures yourself, and with it maybe not quite tracked, and you might get something easily and stitch them together with a stacking program like Deep Sky Stacker or something. And let's see. I can't seem to be able to go to anything else. Oh, there. This was with the luminous channel on the 12.5 inch Ritchie-Crenshaw, and I didn't blow it out too much. The trapezium is there, and these were 15-second exposures. But it doesn't take much more than about 3 minutes before you get something usable. And this is a more aggressive thing here, where you can blow it out. But I encourage you to come up, bring up your camera, and we'd be delighted to put it onto the scope and let you play around. Or if you don't want to play around with your camera, we got plenty of gorgeous eyepieces there. So the next time you hear in the active observers page that the BCO is open for business, please give it a try and join us up there. That's it. Talk to you later.
Michael, you have a question?
No question. I just thought, Reg, you might mention the Daub because we had that out and it has been resurfaced apparently, and it works brilliantly, and it's much easier to use if anybody is intimidated by all the stuff on the major scopes.
Yeah, thanks for mentioning that, Mike. We had a lot of fun up there. I really had a great time. I hope others did as well.
Thank you.
Yeah, maybe we can have a last look. Maybe Joe and Chris can show us their Aurora shots. We've got a few minutes here.
Well, we have about three. And there's still a couple of announcements here to make.
Oh, okay. Well, maybe not.
Sorry. So, I mean, the most important one is next Monday on February. Oh, sorry. Oh, no, sorry. Next Monday is February the 2nd, and then the following is February the 9th, and that is our annual meeting, and we hope it's online. There is no Astro Cafe on that night. And we need to have everybody coming on. We'd like to encourage as many people as possible to come on for the annual general meeting. And so that's a really important one. And then on the February the 23rd, which is 2 Mondays after that, or then we'll be having our dinner at the 4 Mile, and I'm still taking names of people. If you have not already emailed me and given me your name, please do, and I will make sure that you are on the list to come to the annual dinner. This coming Saturday, we are having an Artemis launch party up at the center, and we are focusing on Chris Gainor, who is going to be giving a talk. There's going to be 2 sessions, I believe, 6:30 to 8 and 8:30 to 10:30, something like that. There's two different sessions of times you can come up. If it's really nice, then we'd love to have other people coming up with their telescopes as well. That would be really great. And David Lee and Kirsten are going to be doing a presentation of some things for the moon as well. And we'd love everybody to look at the website and come on up to the center of the universe for that.
I believe JJ Cavallars is speaking as well.
Yes, JJ. Yes, it's you and JJ are going to be
talking about the science, and I can't think of anybody better.
No, yeah, it's going to be great. So I'm hoping, and there'll be things for families to do, and hopefully it will be a nice day. I don't know what the weather looks like, but if it is, it'll be really good to have. So I'm just wondering, are there any other Dave Payne isn't on, I guess, anymore. Is there going to be another Astro Cafe SIG? Do you know, David, at all?
It's the 4th Wednesday.
So that's that will be this coming Wednesday, if there is one.
I think Dave is away. I don't know if he will do it or not.
Yeah, I'm not sure.
But just look. I mean, people that are on the Astrophoto group, they're on a Group IO forum, so he'll announce it.
Yeah. Okay. So the only other things are put it in your calendars. Astronomy Day, International Astronomy Day, is Saturday, April 25th. I believe, and we are at the museum and up at the center for that day. Of course, we'll have lots of things going on, and we hope that everybody that is online here will be coming in person and will be able to see. Miles, I know that's a little tough for you, but we'd love to see you if you can, and have everybody come in to be able to do that. And the General Assembly, as I mentioned last time, will be on May the 2nd and 3rd, which is the Saturday and Sunday. And we'll be giving more information about that as well. And it is 8:59, and I know we have to go.
Thank you.
So thanks for Randy. Thank you, Jeff. Thank you, Chris. Thank you, David, everybody else who put something, and Peter.